Okay, let's go on to our second subtopic, which is on conservation of linear momentum. In this subtopic, you need to be able to state what is the principle of linear momentum, apply the principle, and lastly, differentiate between elastic and inelastic collisions. Okay, so principle of conservation of momentum states that in a closed system, the total momentum should be constant. Okay, or it can also be set as when the net external force on the system is zero, the total momentum of the system is constant. Okay, so mathematically it means that the total force should be equal to zero. Okay, so from the second Newton law, we know that the total force would be equal to the rate of change of momentum. In this case, the principle of conservation of momentum said it should be equal to zero. Hence, the change in momentum should be equal to zero as well. So what does that mean? It means that the momentum is constant. Okay, constant for both horizontal as well as vertical component. Okay, so mathematically you can actually write the initial momentum should be equal to the total of final momentum lah. Okay, right, so that is that. Now we are looking at collision punya theory. So collision pula, it is defined as an isolated event in which two or more bodies exert relatively a strong forces on each other for a relatively short time. So that is what collision is defined. And we have two types of collision, elastic and inelastic collision. We do have explosion, but it's not in our syllabus anymore. So what is elastic collision and what is inelastic collision? So elastic collision is defined as one in which the total kinetic energy as well as total momentum of the system is the same before and after the collision. Okay, and then inelastic collision pula, total kinetic energy is not the same before and after. Okay, tapi total momentum masih lagi conserve. Okay, so the only difference is the kinetic energy. For elastic collision, kinetic energy initial is equal to kinetic energy final, but for inelastic collision does not equal sudah. Okay, so the figure below is showing us a head-on collision of two billiard balls. So theoretically, for elastic collision, after them being collided, they should move in separate ways. And then for inelastic collision, if a ball is hitting a stationary ball, the ball would move together with the same velocity. However, you should be note that not all inelastic collision sticks together. Okay, what makes them different is just the kinetic energy. Itu je yang kamu perlu determine in order for you to know if it's elastic ataupun inelastic collision. Okay, so properties of elastic collisions are as follows. The total momentum is conserved for elastic collision, and then total kinetic energy is also conserved for elastic collision. But for inelastic collision, the kinetic energy is not conserved. Okay, it is not conserved because some of it is converted into internal energy, and then some of it is transferred by means of sound and heat. Okay, so this is why we have considered energy loss in inelastic collision. Okay, but remember, total momentum is always conserved no matter what type of collisions it is. Okay, so that is our subtopic 3.2. I'll be doing example punya videos in the next few videos in the next video. Okay,